Ladies and gentlemen, he's also the adjunct professor at Murdoch University and also visiting scientist at Potsdam Institute for Climate Impact Research in Germany. Will you please make him very, very welcome, Dr. Bill Hare.
Well, thanks for that over-generous introduction. But I have to say, it does feel a bit like a war zone sometimes. I've just spent the week at the UN in New York and the Climate Action Summit on Monday, and the aftermath, including our Prime Minister's address to the UN, actually. I usually work in the international space. I come from here. I know the country, the whole state very well. But I'm going to give you a kind of a top-down picture of the kind of risks and threats that we face. 4 parts, really: what is happening to the climate, projected climate impacts and risks, the Paris Agreement and what it means for us, and the transition risks and opportunities, all in 45 minutes. And what we know is that, I could be longer if you want, but I'm sure Verity will be on my case, though. You will. Okay, I'm terrified. Tempting. But anyway, the global temperature rise is trending at the top of the projections that we've made over the years. And having been involved with a lot of the projections over the years, it gets to be a bit embarrassing when you see how far out our early generation of temperature projections are. The world is warming a bit faster than we would have thought a few years ago. And we also see sea level rise is at the very top end of what we would have expected in over 30 years of projections by the Intergovernmental Panel on Climate Change. Sea level is trending now towards the upper end of projections over that period, which is, as I'll show later, grounds for significant concern. Now, just going into the risks that we face in Australia, warming has been projected, or is observed to be increasing along with the global trend, already a degree warming above the base year period here in Australia. Looking out to the future, in a 4-degree world, which is more or less where we're headed with current emissions trends, you see that by the end of the century, much of Australia would have warmed by about 4 degrees Celsius. Warming to date in Australia is a bit over a degree. I should point out here that we have 2 sets of temperature projections here, one for a high emissions pathway at the top and one for a low one. If we can limit warming to around 1.5 degrees, the overall warming in Australia would be significantly reduced. We're also seeing an increase in extreme precipitation across much, particularly the southern part of Australia, but not only, with increases in observed extreme precipitation events, as well as increasing dry periods happening. These observed changes are expected to intensify, in the southern half of Australia, rainfall expected to decline, particularly in the southwestern part, but not just the southwestern part of Australia. And we're expected to see increases in flash flooding by about 7% per degree of land surface warming. Now, what this translates to is significant changes in the probability of extreme temperatures and rainfall events. This is a very interesting study by colleagues at the University of Melbourne. And you see, if I can direct you to the bottom row here, this is an increase in the likelihood of extreme temperatures. So the high temperatures during southeastern Australia in the drought of 2006 have a very low probability of occurring naturally, but already with the warming to date have about a 35% increase of occurring. But as you see, we get towards 1.5 degree warming, it's about a 50% chance of this happening every other year, and by 2 degrees, a 74% chance. The main story to draw from here is just how rapidly the risks and the high temperature extremes rises with every 0.5 degree of global mean warming. This is a relatively new insight from the science. If you'd asked me 15 years ago, I would have been very sceptical about this. We started to do work on this ourselves in our group about 10 years ago, published some of the first work that showed how rapidly these risks change. And indeed, there's been a whole IPCC report looking at this. But this is a very general point now that we understand every half a degree of warming is leading to more significant changes. Heat waves and drought, the increased likelihood of what have been termed angry summers from the same study is increasing substantially. We know that these heat waves are producing significant economic costs in agriculture, reduced labour productivity and so on, with significant negatives on our economic activity. And that's indeed what we're observing now with the current unusual, if not unprecedented, drought that we're experiencing over much of Australia. These impacts are projected to increase quickly and substantially with every half a degree of warming. We're presently at about 1 degree of global mean warming. As we see here, again, very rapid increases in the likelihood of these events happening with every half a degree of warming. The heat events are associated with and projected to be associated with increasing duration and severity of extreme droughts. The droughts like we've never seen before during the period of European occupation, at least, of this continent. Wildfires are going along with the declining rainfall, increased heat, increased propensity for fire weather to occur. There's been a significant increase in fire weather and fire across most of Australia in the last 20 or 30 years, and we expect, and all projections indicate, that these are likely to increase rapidly in the future. The unprecedented wildfires in eastern Australia and the temperate subtropical rainforests of the east coast are simply that, unprecedented in scale, but are not, but have been predicted for several decades by the scientific community, so it shouldn't be a surprise that they're happening. Crop yields, perhaps a bit controversially, but the most recent research is showing significant negative impacts of a changing climate, the observed warming and rainfall across much of southwestern and southeastern Australia, with significant declines of total factor productivity over the period shown here. I've heard some farmers at talks I've given saying this is not right, but if you go and look at the actual trends across the whole region, then this is what you are seeing in southwestern Australia. There may be individual places where this is not so, but this is likely to continue and deepen as the rainfall declines in this part of the state continue aligned with increased temperatures, which is increasing evaporation and hence stress on plant growth. Now, turning to sea level rise, actually just last week there was a new IPCC report adopted on the cryosphere and ice, and it's come up with some new findings on sea level rise. Firstly is that the rate of sea level rise is actually increasing. It's accelerating, and this is principally due to the increasing and accelerating loss of ice from both Greenland and Antarctica. Greenland contains about 6 to 7 metres of sea level rise if it totally melted, and Antarctica many, many more metres. The other finding here is that the projected sea level rise for 2100 has increased significantly since our last assessment, and that overall the projections now are for up to a metre of sea level rise by 2100 under present emission trends. But what's important, if you look at the figure on the right-hand bottom, you see there's a blue curve. This is for sea level rise under a Paris Agreement type pathway. That is, if we manage to reduce emissions low enough to be on a Paris Agreement pathway, then sea level rise will be limited absolutely, both this century and in the longer term. And I think that's a very important lesson coming from the scientific community, that overall, if we don't reduce emissions, we're headed towards multi-metre sea level rise, even on a few century timescale. But if we can get emissions down, then we can limit these risks. This is very relevant, of course, for the coastal risks in this state. Now, with colleagues, we had a look at the question of how urgent, seems like this is not working, that part of this graph is not working, but I'll talk you through it. We had a look at the question of what happens if you delay emission reductions so that you delay the peaking of global emissions by every 5 or 10 years. And what we found is that the every 5 years delay in sea level rise produces a commitment to a further 20 centimetres sea level rise in 200 years. So often people think about sea level rise as a problem for the short term, but it actually is a problem in the longer term as well. The longer we delay emissions, the greater we create a problem in the future. Sea level rise is, of course, observed to rise around Australia, not the same everywhere, but still significant and substantial, and is causing all sorts of problems in many parts of Australia. Not all of the problems that you read about in the press about coastal erosion are caused, of course, by sea level rise. They often interact with other coastal management problems, location of groins, etc. But the bottom line is that the interaction of sea level rise with those problems will exacerbate and accelerate that. Sea level rise is going to continue under whatever emission pathway we're on well beyond 2100. Here I've got a projection for Fremantle, for example, showing that even under a Paris Agreement pathway, Fremantle could be looking at a half-metre sea level rise or more by 2300 and 35 or 40 centimetres by 2100. Effects that will cause damage to a lot of our coastal assets, tourism and otherwise, which I would say presently not being factored into all sorts of planning decisions. Now, in terms of adaptation, this is a very nice graph which was produced by colleagues for the IPCC report recently adopted, and it shows you the balance of risk reduction that is estimated to be taken very schematically through mitigation, that is reducing emissions, and adaptation. And you see that mostly you avoid sea level rise risk by mitigation, by reducing emissions, but there is still a significant component of benefit to come from adaptation options. And adaptation options vary, of course, they're not generic, they're very location specific, but as a general statement, it gives you an insight into what can be achieved relatively through adaptation. Adaptation is not a panacea. If you're thinking about the agricultural area as well, farmers are indeed adapting around Australia, but already we can see, based on our projections of the likely impacts of climate change on crops, that very soon, in the next decades, the adaptation capacities will be outrun by accelerating warming and its effects. Marine heat waves, very significant in Australia. Very large number of marine heat waves have occurred in the last decade, and they have been attributed to human-induced climate change. So these are having an observed impact already on systems. I'll just run through those in a minute. What we predict for the future are much more frequent and extensive and longer-lasting marine heat waves, including in this part of the world. These will lead to, in the case of coral reefs, more frequent and severe bleaching effects, but also damages to other kinds of marine systems. Here, in the bottom part of this figure on the right-hand side, you see also a graph from the recent IPCC report, which shows the relative change in marine heat wave days across the world's oceans under both a 4-degree pathway, current emissions pathway, and a Paris Agreement pathway, showing again clearly the kind of risk reduction and damage reduction that will come from reducing emissions, reinforcing the earlier story that I showed you in other contexts. The observed impacts of marine heat waves in Australia are really quite extreme, actually. For those of you that have seen what happened in Shark Bay, you'll know what I mean. Really massive loss of seagrass meadows and so on. The damage at Ningaloo, etc., is clear to see for anyone who will look for it. And it's been reported thoroughly in the scientific literature. Of course, marine heat waves have had a bigger impact on fisheries in Western Australia as well. Shark Bay looks like being on the front line of global warming impacts because of its shallow character and so on. For the future, I think marine heat waves are predicted to cause large ecological and socio-economic effects in the Shark Bay region, in fact that whole Ningaloo coast, for a variety of different reasons. The Ningaloo coast, of course, one of our World Heritage areas as well, is experienced extreme bleaching, and we expect to see these problems get significantly worse worse, both with the rise of warming and the increase of ocean acidification. For coral reefs in general, and there are a lot of coral reefs in Western Australia. Everyone talks about the Great Barrier Reef, but we have great coral reef systems stretching from the Gascoyne coast up into the Kimberleys. And unfortunately, they're on the very front line of climate change. The IPCC report has again found that basically by the time you get to 1.5 degrees, most tropical coral systems will be at risk of, let's say, just plainly wipeout. Projections that we did a few years ago put the risk of coral reef degradation at 70% at 1.5 degree warming. By the time you get to 2 degrees, 99%. The scientific literature since then has tended to confirm that. But what you can see here is even if we limit warming to 1.5 degrees, the prospects for coral reefs are not great. And of course, adaptation, ecosystem management, coral transplanting and so on play a role in helping reefs to recover, but unless we can limit warming, there simply is not a future, I'm afraid. Fisheries, not an insignificant issue in Western Australia, whether you're a recreational fisher or a commercial fisher. What we see are really significant problems coming with fisheries. This is another graph from the IPCC report just adopted. RCP 2.6, that figure on the middle, is essentially a Paris Agreement pathway, a bit warmer than that, about a 2-degree pathway. RCP 8.5 is a 4-degree world. The scientists love their acronyms, I'm sorry, but that's what they do. But what you see here, if you look at the Australian coast, see under a 2-degree pathway, RCP 2.6, losses of around 10% in potential maximum catch potential. By the time you get to RCP 8.5, the 4-degree world, losses are extending to 30 to 40% in maximum fisheries potential around this coast. And this reinforces a global picture. You'd have to go up to the Arctic to find any significant improvements in most places, or the far southern ocean. So that's going to have long-term implications for our industries here and also the recreational side of things. Fisheries in Australia are observed also to have had significant negative impacts. As you see here, the line that I've highlighted here shows that around the Southern Ocean, temperate Indian Ocean, significant adverse effects have already been observed and attributed to climate change. Now, in relation to land, the IPCC, always helpful, published a report on climate change and land early this year as well. And if I can get a pointer going here, let me see. Maybe I can't. Well, look, here is a classic IPCC attempt to show and synthesize thousands of papers into a risk scaling from low risk to very high risk, and the purple. And the thing to notice here is that looking at dry land, soil erosion, vegetation loss, wildfire damage and so on, things that are most relevant to this part of the world, you start to get into high or very high risk by the time you get to 2 degrees warming, and in some cases 1.5 degrees. So that's a very generic global summary, but what it shows is that the current scientific assessment is that land is under risk from climate change, and already we are observing those risks happening. And this is going to have consequences for land management across the whole of this state, and which, as far as I can tell, are not yet factored into adaptation planning. Now, in case you don't really care about the environment, I just thought I'd put up here an estimation of the economic damages which are projected to occur. The top figure shows a 4-degree world, which shows substantial to extreme economic damages under a 4-degree warming. And Australia is not immune from these damages, looking at a percentage reduction in GDP per capita. Thanks. So here we've got about the same reduction of GDP per capita under a 4-degree world as China or the USA. Looking at the bottom, there's a comparison between a 2 and a 1.5 degree world here. This is the benefits of reduced damages under 1.5 degree warming versus 2 degree warming. Probability of that. Australia has a significant probability of benefiting in terms of reduced damages, and the probability of reduced economic damages here is shown to be quite large for Australia as well by the end of the century, under 1.5 versus 2 degree world. The point here is that often the debate in Australia about climate change is framed in purely economic terms without consideration of the factors I've mentioned, but it's also clear from the state-of-the-art modelling of economic impacts of climate change on economies that Australia is one of the more vulnerable countries in the world in this, and would benefit immensely from reduced emissions. So what needs to be done? Well, we have the Paris Agreement, a groundbreaking agreement adopted in 2015. The agreement is long and complicated, but one of the key parts of it is its long-term global temperature goal, which in a nutshell talks about working towards holding warming well below 2 degrees and limiting it to 1.5, the 1.5 degree limit in the Paris Agreement as it's now well known. And of course, countries are now working on trying to implement this, but the question is what needs to be done globally and how does this relate to Western Australia? What we know from the science is that emissions of greenhouse gases need to be reduced to zero sometime around in the 2060s. That is total greenhouse gas emissions from all sources, including land, energy and so on. And that needs to come down to zero, and you'll see also, worryingly enough, negative, which I'll come to in a minute. Reason it has to go negative is because we've waited so long to act that there's so much carbon in the atmosphere that in order to limit warming to even 2, especially 1.5 degrees, we have to take CO2 out of the atmosphere. That's where we are now due to the legacy of inaction. So we need to peak emissions as soon as possible, around 2020. As I'll show in a minute, we're not heading that well at present. Emissions need to be reduced to approximately half of 2010 levels by 2030, which is a big ask, and then, of course, go down towards net zero around 2070. And then we have to have negative emissions. I don't think that's showing up here, but I'll look at it here. So what's interesting here for the land sector, this is a view of the same pattern of emission reductions that we see coming out of all of the global studies. Peaking emissions 2020, 50%, roughly 45% below 2010 by 2030. Zero emissions for all emissions by around 2065, 2070. Carbon dioxide emissions have to be zero by around 2050, right? But here you see green is the land sector, emissions from agriculture, forestry, that other acronym AFLU, who knows what AFLU is? Yeah. So that's agriculture, forestry, land use change, transitioning from a global source, right, to, during the 2020s, a global sink, that is sequestration at multi-gigaton scale. This is about 2 or 3 billion tonnes of carbon taken out of the atmosphere and put into vegetation and soils. The yellow is what the models assume will be done with carbon dioxide removal, either with biomass, energy, carbon capture and storage, another land-based measure in effect, not without its problems actually, or more direct technologies such as carbon dioxide removal technologies on their own. What this story is about here is that not only do you have to reduce CO2 emissions and other greenhouse gas emissions, but you also have to be turning over the source in the land sector globally into a sink globally, which is a big challenge and something that I think you people here would know a lot more about than me. But that has to be factored into all of our thinking about adaptation, resilience and mitigation. Now, in terms of what we have to do to get onto a Paris Agreement pathway, the short answer is absolutely everything. This is just how it looks, basically. So the electricity sector needs to be achieving zero emissions globally before 2050. Coal needs to be out of the power sector by 2050 at the latest. Very large penetration of renewables by 2050, 75% or more. Electrification of nearly everything is a general theme. You can think of anything that is running with a motor of any kind, an internal combustion engine, even industrial heating. Electrification is the rule to decarbonise. So transport, batteries, hydrogen, and so on, as well as modal shifts and better planning of transport. Perth has a challenge here. I looked up how to get here today from Fremantle. 1 hour and 45 minutes on public transport was not optimal. But I'm just saying. So, and then, of course, in industry, here we're talking, steel making, even LNG manufacture, etc. Electrification is the way to go. In agriculture, forestry, there's a variety of different options, but they include sustainable agriculture, shifting diets, using food waste, land restoration, so on, things which I'm sure this group is very expert in. It all has to play a role and simultaneously. So one of the big stories is that globally coal needs to be phased out quite rapidly. So Western Australia, of course, is now backing out of coal quickly, and a whole bunch of countries actually are, but a whole bunch of countries are actually not.
Queensland is not.
Queensland is not, and there's even, as we know, a discussion of expansion or support. So very big story. It's a big theme in New York last week. Some countries really still promoting coal, our own included in that, actually, unfortunately. But a lot of countries also indicating an intent to phase out coal, some not soon enough, but working on it. Chile, for example, has set a 2040 phase out for coal. And I think working with the Chileans, it looks a bit earlier than that, but they're not ready to announce that yet. Maybe we hear some news at the end of the year in Santiago. Germany's got a 2038 phase out, but is likely to come forward by some years, I think. And so this is happening for a variety of different reasons, not just climate, but often for economics, but it needs to happen quickly. But what's relevant to this state, though, is natural gas. Natural gas is interesting because it's often claimed that natural gas is a bridge to a cleaner future. I guess the short story is no, that natural gas can play a role in power sector transition, so you replace coal with renewables and gas to back up the system or provide peaking capacity when variable renewable energy is not online or storage is not available. But what you see out of the energy system models is, this is for Asia, from a study we did with UNAP in Bangkok on decarbonising Asia, a little subject, that we looked at what the models are saying about natural gas in the power sector in Asia, which is, of course, our principal demand for natural gas from Western Australia, already peaking by around 2030 or the mid-2020s and dropping quickly in a 1.5 degree pathway. So the outlook for natural gas here, if the world decarbonises, is not as robust as many in the natural gas industry would like us to believe, I'm afraid. And I'll come towards the end of my talk to the possible solutions for that. The bottom line is that natural gas has to decline and quickly. We don't think there's going to be a role for the use of carbon capture and storage in gas power plants. That will be the way to reduce emissions from natural gas in the power sector by 85% or so, because it's too expensive. Now, let's turn now to seeing what is being done about the climate change problem before turning to some of the opportunities in this transition for Western Australia. You mentioned the Climate Action Tracker at the beginning. This is our most recent effort to estimate where the total of countries' nationally determined contributions, as they're called, NDCs is the code word, under the Paris Agreement, are putting the world. Essentially, what we add up is that the pledges and targets, the NDCs, under the Paris Agreement, are going to warm the world by 2.9 degrees Celsius as a median estimate by 2100. The current policies in place around the world are a bit warmer at 3.2 degrees. So we're not really heading in the right way right now. There has been some signs of progress the last few years, but really it's not accelerated in the way that one would have hoped. It's also important to note that we have an uncertainty band here, which is a product of both the emissions uncertainty and the climate modelling uncertainty. Our uncertainties in being able to model how the world is going to respond. The 4.3 degree warming up there essentially says that under current policies, there's a 10% chance of temperature exceeding 4.3 degrees, 1 in 10 chance by 2100. So there's no complacency to be drawn from these numbers at all, I'm afraid. Now, the emissions gap, the gap between where emissions need to be, which is the green curve, the 1.5 degree curve, and where current policies are heading is quite large. So in 2030, you've got a multi-gigaton gap between where emissions are headed to under current policies and pledges and targets, the NDCs, and where they need to be. So this gap was the gap that was meant to be closed at the UN Secretary General Summit on Monday last week. We are still working out if anything happened at all there, but my impression is not really. I mean, he's basically arguing that we have about 59 countries who've indicated an intention to update their NDCs with more ambition, but they just didn't announce it on Monday. So we have to wait and see there, but certainly my feeling out of that summit was some disappointment, actually. Now, what are we seeing globally in terms of emissions? There had been some enthusiasm over the last few years that CO2 emissions had begun to peak, but the most recent data we looked at in June this year tells a different story. Actually, CO2 emissions have started to increase again from 2017 to 2018. And one of the largest problems is that natural gas is booming. It grew about 4.6% over those years. So whilst coal is making a bit of a comeback, it's not the largest source of the increase, actually. So that is an ongoing problem that we're seeing as well. Now, the international process is now focused on updating the Paris Agreement NDCs, nationally determined contributions, by 2020. That's the big bang here. And the summit was just last week, leading towards this. And we're hoping to see that, let's say, more announcements at the UNFCCC, the Climate Change Conference of the Parties in San Diego, COP25. But we would really need to see very significant offers from countries to increase their ambition by 2020 to put the Paris Agreement onto a track where you could say it's likely to work. Now, where does Australia stand? Well, we heard last week that Australia is a very small emitter. This is what Mr. Morrison said at the UN, 1.3% of global emissions, and therefore it was up to bigger countries to act. The reality is that if you looked at all the countries that are under 2% of greenhouse gas emissions, it stacks up to around 29 or 30% of global emissions. So the bottom line is that setting aside anything else like wealth or capability, if all the small emitters said, look, it's up to China or the US or the EU, we frankly would not be able to solve the problem. So every country needs to play its role. Domestically, our own emissions are rising. So we have we have an actual increase the last 4 or 5 years and projected increase until 2030. I know the government keeps on saying that they're going to meet their commitments at a canter, but I don't know anyone in the expert community who can understand that. The overall trajectory of where Australia needs to be, step through this figure here, the green, the Paris Agreement range, we calculate, a Paris Agreement compatible domestic emission range would be something between 35 and a 55% decrease by 2030 from 2005 levels. The present government's position is 26 to 28% reduction. This, by the way, is excluding land use change and forestry. So the numbers aren't what have been converted from direct excluding land use change and forestry. But overall, you see the reductions are nowhere near where they would need to be for a Paris Agreement compatible range. So that's our present issue in Australia, that our emissions are going up when they should be going down. And the present policy of government is not to get emissions anywhere near where they need to be, which has the effect of, is likely to have the effect of imposing greater and more expensive obligations on future governments and future generations who have to take faster and more expensive action. The government also likes to say that our per capita emissions are doing very well. Unfortunately not. If you translate our Paris Agreement NDC into per capita emission terms, for 2030, you can see that basically it doesn't really stack up very well, that even the US, with its present non-participation in the agreement, is headed towards a level very close or a bit below Australia. China and the EU continuing a low trajectory on per capita emissions. So essentially the per capita argument is not stacking up. Not that the atmosphere particularly cares about per capita emissions, it cares about absolute emissions. So, and the Paris Agreement commitments are written in terms of absolute emissions. In terms of exposure, exposure of Australia to the global carbon controls under the Paris Agreement, presently we are accounting for our exports account for about 3.5% of global CO2 emissions, export of gas, coal, for both thermal and metallurgical use in iron and steel making. So we are quite exposed, if you like, if the world starts to reduce emissions. Our market will not stay as high as it is as the global market for carbon-intensive fuels declines. Now, looking at the opportunities. The dominant issue out there in the energy sector is the cost of renewable energy. It's dropping dramatically, and this figure shows some examples of different estimates of renewable energy. I have wind and solar, both small and utility scale. These are different estimates published over the years showing how, as you go forward in time, the total cost of technology actually observed in the market is dropping. And we put on here some more recent projects which are later than either the Lazards, which is a standard in the area, or the IRENA, International Renewable Energy Agency estimates showing that already at utility scale, the cost of wind is well below the fossil fuel range here, and the same for utility scale solar. And already you see some of the costs in this area, including storage, are very low as well. So you're seeing in many markets in the world where utility scale photovoltaics plus batteries are outcompeting natural gas turbines, for example. So that's a very important economic dynamic which plays into the situation in Western Australia. The rollout of renewable energy is much faster than expected. This is a very interesting picture from the Renewable Global Futures Report, which shows previous projections of the growth of wind energy. And you see that the real wind market has grown dramatically faster than virtually any of the projections, apart from our own in 1999 up here. So that's just exploding, and the same thing happens if you look at the photovoltaic market and now the battery market. So for Western Australia, many have observed that because we have such a high availability of renewable energy, we have the potential to become an exporter of renewable power, either directly via a cable or to Southeast Asia, or a series of cables, or through hydrogen exports or other energy carrier. So the reason why is that if you look at a map of the combined power density from wind and solar energy, Western Australia, along with some other places, has a very high total availability of wind and solar. So, for example, in the Pilbara, you get a lot of sun during the day. I think you've all noticed that. And at night time, the wind blows faster. So you have both wind and solar, which gives you a very high availability factor for variable renewable energy in that part of the state. That's led to quite a lot of interesting ideas, some of which are developing to pre-commercial stage, including the very large 15 gigawatt West Australian Renewable Energy Hub project up in the Pilbara region, which has the idea of exporting electricity or hydrogen to Asia. I'm not sure they know which way they're going to go yet. They were presenting at a meeting in New York last week, and it seemed to still be unclear as to whether they're going to go for a cable into Southeast Asia or green hydrogen exports. Certainly from the Asian market point of view, what I heard for example, from the Japanese Minister for Environment, Koizumi, is that Japan is looking for a lot of green hydrogen. They are very sceptical about brown or blue hydrogen, brown being hydrogen made from coal, which would be a bit of a mess, and blue hydrogen, being that made from natural gas, would be a slightly lesser mess, but a mess nevertheless. So, and also what you hear from Chinese colleagues is very much of an interest in hydrogen, not just for climate change issues, but also for reduced air pollution. So burning natural gas turbines also contributes to local air pollution problems in their cities.
Can they talk about the nuclear facilities?
China is moving ahead with building nuclear, but very slowly. They're way behind. Japan always talks about building 20 new nuclear power plants. They have to turn the ones that were shut down on. I think they turned 3 on. I'm sceptical. I don't think they'll do it. They also have they've been talking about a big pipeline of coal plant as well, but that seems to get cancelled every few months now. As you know, the finance industry gets increasingly wary of investing in those facilities, and they're looking more at renewables, and they're looking in particular at importing hydrogen from places like Australia, or I should say South Australia right now. So there's an opportunity here for Western Australia. Western Australia has a lot of opportunities actually due to its vast renewable energy potential. We have a gas infrastructure, and that actually creates a very interesting transitional opportunity. LNG manufacture is very energy intensive. I think about 8 to 10% of the gas taken out of the ground runs the LNG production facilities, and about 80% of that is used essentially to make electricity or to do things that could be replaced with electricity. So a first transition for the LNG industry here could be to move into renewable electricity supplying its gas compressor and manufacturing, which would then reduce its emissions by, I guess, 80% or so, its domestic emissions. In the longer term, as the market for hydrogen builds up, that infrastructure available for natural gas, part of it could be transitioned towards supporting the hydrogen export industry. So, you know, we have, in that way, both hardware and the software in terms of the engineering skills and capabilities in Western Australia at global scale to actually bring off this transition if we're fast enough. I've just got 50 minutes left, or was that 5? Right, okay, good. No, I'm well on the way here. So it's a great opportunity for Western Australia because of all of the aspects that we have here. We have a renewable hydrogen strategy, which is the first step in the right direction, and we have a net zero target for 2050, but we don't have an intermediate target for 2030, which I think is quite fundamental. Other states are moving ahead a bit faster than Western Australia. I know South Australia has just announced a 100% renewable strategy, which is coupled to a very big ambition for exporting renewable hydrogen. Hydrogen can, of course, be used in many industries. It could be replacing natural gas for alumina production. You could also, new commercialised technologies are producing steel directly with hydrogen, eliminating the need for coking coal, meaning the only emissions are basically water. So that's something that could be considered in this state as well, but it does require a bigger vision to be developed by government, because when you talk to industry here, they're saying, well, we can't really do anything until we get a strong signal from government. So in terms of the opportunities here, there needs to be an overall strategy in line with the Paris Agreement, the rolling out of renewable energy at scale, and in most places, including in rural Western Australia, I think is a major priority, because then it will give us not just renewable energy, but a lot of learning in these kinds of grid developments. And that learning becomes important intellectual property, which will be applicable in many other parts of the world. So in general, there's a lot of opportunities here, including in the Pilbara, remote communities, agricultural regions through sustainable biomass production. I showed earlier that the models are essentially showing that we need a lot of negative emissions. The technology of choice in the models right now is biomass, energy, carbon capture and storage. But biomass energy systems at smaller scale in this state could be a very useful intermediate step towards providing both electricity and fuels for transport. And these opportunities really are out there to be taken. And I think it's something that Western Australia needs to work a lot harder on taking, as other states are moving ahead a bit faster than us right now. So thank you for your attention.